Hi, everyone. Welcome to Birch Talks. Today, we're going to be talking about climate change, weather, and climate extremes. Let's jump right in. My name is Matt Chalmers, CEO and founder of Birch Citadel, and we're here to help try and break climate down a little bit and make it more accessible. Welcome. Today, we're going to be doing an in-depth assessment of some of the latest developments in weather and climate extremes. In this video, we're going to explore from the perspective of the IPCC AR5 discussion on extreme weather events around the world. We're going to be exploring observed changes, their attribution to human activities, and projections under various global warming scenarios. We're going to be talking about regional and global trends for temperature extremes, heavy precipitation, floods, droughts, storms, and compound events, drawing on the latest data that we now have available from the global climate science community. Just as a disclaimer, I know for everyone out there that is a climate scientist who's really deep into this field, we're going to be skimming the surface of a massive amount of data. My goal here is to try and break this down and make this complex and dense topic a little more accessible to the broader community. So those of you who are in the field, I see you and I hear you. I just ask that you hang with us as we try and do the science communication exercise of making something that affects all of us more accessible to all of us. And as always, I look forward to your feedback in the comments. Always happy to chat. So this chapter, we're going to be focusing on land regions, excluding Antarctica, and this is going to complement a video on marine climate extremes that we're going to be doing down the road. We're going to be drawing on, once again, latest knowledge from the AR6 report, and as a result of that, we now have a much more robust understanding of how these temperature and climate extremes are evolving under increasing global temperatures, and especially as we're going through and examining different scenarios ranging from a 1.5 degrees centigrade to a 4 degrees centigrade type of scenario. So let's go ahead and start off with a brief conversation on advancements and updates since the latest global science report, the AR5, and what new knowledge we have in the AR6 when it comes to extreme weather events. Since the fifth assessment report, there have been significant advancements in our understanding of weather and climate extremes. Of particular interest, this includes new insights into the attribution of specific extreme events to human influence, particularly for droughts, tropical cyclones, and compound events. This is a real breakthrough. In the past, anybody who's been following climate science until now, it's been much more challenging. In fact, one of the greatest challenges is to have discussions about particular events. So now that we're able to look into these with more granularity, this is a really exciting development. The other thing is that AR6 presents a much stronger regional perspective. We have much more granular data on how different weather events are evolving at local levels. This really provides us with a very helpful foundation for more targeted adaptation strategies at not just the global level, but going down into the regional level, local level, and sometimes even community level. So let's go ahead and dive into this by looking at some of the key observed changes and the role of how human activity is shaping these events in a more specific manner. So here we're going to be talking about observed changes and attribution to human influence. So as we all know, one of the most well-established conclusions from years of IPCC reports is that human-induced greenhouse gas emissions have unambiguously significantly contributed to the increased frequency and intensity of several types of climate extremes, and particularly temperature extremes. The evidence for this is especially strong in the case of extreme heat events. Recent heat waves, North America, Europe, these would have been highly unlikely, extremely unlikely, without the influence of human-driven climate change. So as we increase atmospheric concentrations of greenhouse gases due to human activity, we know that these types of events are going to become both more frequent and more severe. That said, this is about more than just heat. So human influence has also been linked to changes in heavy precipitation and droughts, tropical cyclones, and other compound extremes. The data that we're seeing in AR6 strengthens the attribution of these extremes to a combination of greenhouse gas emissions, aerosol emissions, and land use changes. We can now see the impact of specific policies on our world. So speaking of specific policies, let's go ahead and speak about regional changes and how they've been scaling with global warming. Again, as we know, the relationship between global warming and regional climate extremes has never been clearer. The intensity and frequency of these extremes generally scales with global temperature increases. So even when we're dealing with relatively small changes, such as maybe just an additional 0.5 1.5 degrees centigrade of warming. This is something that can result in statistically significant increases in extreme events. In other words, as we're cooking the world, we're going to see more of these problems and they're going to get worse. Let's dive in and unpack this a little bit, especially when we're looking at temperature extremes. The likelihood of unprecedented heat events. So now we're talking not just about it's a heat event that's noteworthy, we're talking about a heat event that's never happened before. It's something that's unprecedented. The likelihood of this happening rises sharply with each incremental increase in global temperature. As we're really digging into the data on AR6, it just highlights that frequency and intensity of these events is going up. At the same time, we're also looking at the frequency and intensity of heavy precipitation events. That's also going to increase with higher temperatures. Now we're talking about tropical cyclones. We're talking about hurricanes. All of these are projected to become more intense in a warming world. To break this down a little bit more, when we're dealing at the 1.5 degrees centigrade level, we're going to see an increased likelihood of heat extremes. At 2 degrees centigrade, major effects, we're going to see more frequent heavy precipitation and stronger cyclones. And then when we get to 3 degrees centigrade, we're going to start seeing severe impacts happening across multiple regions. This is a global systemic phenomenon, and we understand now it's a function of temperature. Now let's go ahead and switch over to a discussion about what climate scientists are calling compound events and their growing importance. So I just want to emphasize, when we're dealing with climate change, fundamentally, this is a complex system. There are different systems that make up all of the network of systems that drive everything that we're seeing here. So this is a really complex field. One of the things that means is we have different effects interacting with different effects. And this leads to the rise of what are called compound events. This is a situation where there are multiple different kinds of climate extremes that are occurring simultaneously or consecutively in a way that amplifies their overall impact. So in other words, we're not just dealing with a situation where, hey, we have this hurricane, hey, we have this heat wave, hey, we have this or we have this. No, we're now going to be dealing with a situation where each of these things is now going to be impacting the other. And what we're going to have to deal with is now going to be more complex and more intense because of these negative synergies that are going to be occurring. So here's just a classic example. The combination of extreme heat followed by prolonged drought can create conditions that are absolutely ripe for wildfires. And this is what we've seen across the Western United States. We've seen this in Australia. We've seen this across the globe. Similarly, when we're dealing with tropical cyclones that can bring both more intense rainfall and storm surges, both of those are going to exacerbate flood risks that can be really destructive to coastal communities. So AR6 emphasizes the growing likelihood of these multivariable events occurring as global temperatures rise. The more our world heats up, the more we're going to start seeing these synergies and these compound effects that are going to make it more challenging for us to address these concerns. Now, let's go ahead and switch over and let's talk about what we can project, the different scenarios that we can see, and what we should expect to see moving forward under different levels of warming. So ultimately, what level of warming we see is going to be dependent on all of our collective actions as a species, as a global community. This is something where all of our actions in total add up and matter. We don't know exactly what is going to happen. We don't have a crystal ball, but what we can do is we can say, okay, given this input from our collective action, this is what would happen. Given our collective input, this is what would happen. And this is what allows us to build what are called different scenarios. And those scenarios allow us to explore what is a world with 1.5 degrees centigrade warming going to look like? What's a world with 2, with 3, with 4 degrees centigrade warming going to look like? And then based on that, we can make some educated predictions about what we should expect to see under each of these various scenarios. So even though these are projections, they do still provide us with critical insight into the risks that are associated with continued warming. So let's start off with a moderate, gentle 1.5 degrees centigrade of global warming. Not that there's anything moderate about this. This is unprecedented, but compared to what could happen, this is a moderate case. Here, even in this moderate scenario, we already see a significant rise in temperature extremes and heavy precipitation. As this rises up into 2 degrees of warming, the intensity of these extremes is going to become even more severe. We're going to see droughts that are worsening in some regions. We're going to see floods that are increasing in other regions. We're going to see sometimes the same thing happening in the same region, which causes all kinds of problems. And the incidence of tropical cyclones is going to become more intense and more frequent. Imagine a world where we're running low on water. We've got this drought, and all of the water that we need in order to ameliorate the drought slams in rapidly and in a destructive manner. this is not a recipe that anybody wants to deal with on a local or a regional level. Now let's talk about what happens as we start closing in on 3 degrees centigrade and above. We're looking at a zone where extremes aren't just extreme, they're unprecedented extremes, where you see this record-setting kind of temperature increase. You see a record-setting drought, and then it happens again, and then it happens again, and then it happens again with increasing severity. So certain events are occurring at frequencies that are far beyond what we've observed over the course of the past century, with intensities that are also far beyond what we've observed over the past century. And that's something that in this scenario of 3 degrees and above, we should expect that's going to just continue to worsen over time. Obviously, not a scenario that any of us want to actually live in. Now let's go ahead and have a conversation about the role of regional projections in climate adaptation and in planning. So as we mentioned before, one of the most critical advancements in the AR6 is the increased availability of regional projections for climate extremes. This is really exciting because these regional assessments allow for much more precise adaptation planning by not just state level or sub-state level, but regional and even local and even community level adaptation planning. This helps policymakers and those communities have the kind of information that they need to thoughtfully, carefully, and cost-effectively address the specific local vulnerabilities and specific local challenges that they're going to be facing. So even though we're facing a very serious problem here, the amount of information that we now have to bring to bear is going to help us do something about it in a much more precise and thoughtful manner. And that's good news as we're facing this warming world. The other thing that I want to emphasize is that different regions are facing unique risks. And the more granularity that we have in this data, the better job we're going to be able to address these risks and prepare for these risks in advance. So just to rattle off a few examples, South Asia is projected to experience more intense monsoon-related floods, while parts of Southern Europe are also going to be facing longer, more intense droughts. So this sort of extreme separation out that varies regionally is also a feature of climate change. The way to think about where our world is going is one size does not fit all. This notion that, oh, well, the planet's getting warmer, so everywhere is getting warmer. No, it's much more complicated than that. We're dealing with complex systems, and the way that each of these complex interrelated systems deal with this global stressor is going to be expressed differently. So we need to be ready as a society, as a civilization, as a species, to face this increasing diversity of problems that we're going to be facing. It's not one problem fits all. It's lots of different problems, and sometimes they're very contradictory problems. Now let's go ahead and switch over our conversation to unprecedented events and some of the uncertainty that we have in our projections. Let's have a conversation about what kind of data we're confident in and the limits of our confidence. So while we have a robust understanding of many different kinds of extremes and where those extremes are going to occur and what we should expect from those extremes, there are some uncertainties that remain, particularly around rare and unprecedented events. Once again, we don't have a crystal ball. We can't look into the future perfectly. What we've got are increasingly granular models, and we've got a lot of good data and a lot of good data that confirms a lot of the different theories and predictive models that we have. But when we're dealing with unprecedented events for the first time, we need to make sure we understand the limits of our data. Here's what we do know. The projections show that as global temperatures rise, the probability of extreme events outside of the current observed record is going to increase. How frequently those are going to occur, we have some limited data on that because, again, we're dealing with unprecedented events. How intense those events are going to be, that's, again, something that we've got limited data. But what we can say with confidence is there will be more. They will be worse as a function of global temperatures rising. It's also very difficult for us to attribute those unprecedented events with precision. As our data granularity improves, we can do a better job. But again, it's going to be challenging to point at this particular heat wave and precisely attribute it. When we're dealing with these kind of outlier events, while they are currently rare and might become less rare over time, they do carry a lot of risk. They are still going to be, and actually might even become more difficult to predict with precision. This is a really profound point because when it comes to preparing for climate change and the future of our world, it's not like we can say, hey, this earthquake is going to happen here or this hurricane is going to happen here. What we can do, however, is we can say, hey, there are going to be more of these coming. We should prepare for them as a category rather than let's prepare with pinpoint accuracy for this one particular tropical cyclone to occur. So as such, the AR6 report really highlights the importance of including these low low probability, but very high impact, high destructive, high risk events in our risk assessments and taking policy action that is consistent with protecting ourselves from them. So in other words, they're going to get worse. We don't know exactly when they're going to happen, but we know the worst events are coming. So we need to make sure that we're ready for worse events, regardless of when they come. That's an important point. That's a really big, important piece of data coming out of this report. So where do we go from here? Let's talk about the path forward as it pertains to climate mitigation and climate adaptation. Ultimately, as we all know, the future trajectory of climate extremes is dependent on our collective efforts to all do our part as a species to mitigate global warming. This is at the heart of climate mitigation. This is let's stop the bleeding. Let's stop making the problem worse. Reducing emissions will slow the rise in temperatures and help limit the worst impacts at these temperature extremes. Obviously, that needs to be a really important part because we can't just see this line continuing to go up forever. However, just to be honest, we're now at a point looking at the data here where climate adaptation is a reality. Our world is changing. It will continue to change, at least to a certain extent, regardless of what we do or do not do. Now, it's really important that we stay on it to make sure that it doesn't keep changing too much. We can limit the amount that it's changing, and it's really important that we do. But we are no longer at a point as a species on this planet where we can stop the change at all. That window has closed. We must adapt to our new world. So when it comes to looking at the data here, the importance of this data is not just to provide projections, but to use this data as a tool to help policymakers at every level of government, from international to collective groups of nations to subnational actors, to regional, to local, to community level, to work with those communities, work with their stakeholders to ensure that the latest and most accurate and most granular science is being used to help inform the strategies for both climate mitigation and climate adaptation. Let's use the information that we have to make sure that we're being smart and we're being cost effective about how we're going to solve this problem. At the end of the day, as we continue to refine our understanding of climate extremes, we have to think about how we're going to translate these insights into actionable solutions. The science could not be more clear. Now it's about how we use this science to apply that knowledge collectively to create a more resilient and sustainable future. I believe that we all have a stake in this. All of us are impacted by the changes to our world. A lot of the science is really complicated. A lot of what we've covered today is really complicated. But at the end of the day, I disagree with the idea that you, dear listener, can't handle the information. One of the things that I'm really passionate about is taking everyone seriously and sitting down and having the conversation with a clear eye on the data, informed by the cutting edge of climate science, and equipping you as best as we possibly can with a clear vision of what's going on. We all have a stake in this. I believe all of our voices matter for something in this. And I'm really passionate about helping everybody understand not just the concept of climate change is bad, we need to act. I'm really passionate about bringing that same granularity of data to you here so that we can all have a conversation on the specific and the details of how we want to move forward in a way that's informed by first principles, informed by the best global cutting state-of-the-art science that we have. So thank you very much for joining me in our conversation of extreme weather. I hope that you found this useful. I recognize for all the climate science professionals out there that this was a very brief skim on the surface of a very deep lake. And if there's interest, I look forward into really diving in much more deeply into those depths. Let me know in the comments below if that's something that you're interested in. And I look forward to next time. Thank you so much. Have a good one.